Hello, everybody. My name is Max Singman.
And I'm Joey Shepard, and today we're going to be presenting hybrid satellite networks, some of their vulnerabilities and potential defenses against those vulnerabilities.
So, a hybrid satellite network is a network comprising of the space segment, the link segment, and the ground segment. Terrestrial networks connect to high altitude platforms, here depicted by an airship, which relays data down from the satellites. Satellites send the data down to the airship using free space optics. However, the airship has to deal with the weather when it gets this data down to its users. And during bad weather and adverse conditions, UAVs, which is depicted here on the right by the drone, are sent up to receive the optical link and increase the user coverage and line of sight probabilities. Using this network architecture, latency is reduced and users get access to more bandwidth through a higher data rate. However, this network also has vulnerabilities. And as this OV1 diagram is showing, this network can be taken down through a multi-layer attack. You see, if an adversary finds out the exact wavelength the light signal pulses are being used, it can replicate the pulse and send it at the detector located at the UAV. The UAV will mistake that signal for the one it's expecting, and all communication is cut off from the ground terrestrial network. This will then prompt the high altitude platform station at the top to switch back into RF mode, since RF can penetrate through the clouds more easily. But if simultaneous jamming is done on wideband frequencies, the RF is no longer an option for getting the data down to the users. And so the HAP is cut off from the terrestrial networks and only has a communication link established with the LEO. This is an effective way to infiltrate the network and ensure that no data is able to get through.
And so there are a few ways to defend against an attack like this. The biggest thing that you can do is to add a what's called dual authentication, which is a potential for the UAV to employ both RF and optical links to keep adversaries from spoofing the optical link by making it more difficult for the adversary to get the correct frequency, wavelength, encryption, all of those important parameters, and spool the UAV into accepting its data link rather than the one that it is supposed to be accepting. Um, as for jamming on the HAP in the RF jamming, employing something such as a frequency agile transmitter would allow for, at a minimum, momentary shifting in the RF spectrum to allow for the HAP to continue to get the RF down to the ground station without being affected by the adversary. However, there are some potential downfalls to that. Right, the adversary can just continue to jam on the other frequency that you've just shifted to. So not a perfect defense, but something that definitely can help and at least allow for your physical ground assets to go find the source of the jamming and hopefully stop it. Another form of security and defense that needs to be addressed is the ground stations themselves. There is potential for the adversary to attack from the ground. This is something that is, a little easier than a traditional satellite network, and something that is often not thought about, just because you have more access on the ground. Ways to do this are to have physical controls such as physical security and pins employed to ensure secure access to keep your ground network from being infiltrated.
So while this architecture still needs a lot of testing, it is still the most prominent way we have today to expand the global demand for connectivity and remote user access to broadband connection. Thank you, everybody, for listening.
Thanks.